Hello. Hi. You are muted.
Is it all good now?
Yeah, now it's good.
Yeah, hi. Just logged in to see that everything is good or not.
Yeah, if everything is working great, we can start in about 8 to 10 minutes,
Yeah,
right?
yeah. I'll just try to see if I can share my screen.
Okay. Yeah, I can see
Can
the,
see
the
my
code.
screen. Yeah, that
Okay, it's all good.
it works, right?
Yeah,
Cool. Good.
everything is great.
Yeah, no, I'll just wait first.
Okay, see, I'll just introduce you, and then after that you can start,
Yeah,
and
that
in
should be
the
good.
end we'll have a Q&A. Okay.
Yeah, sure.
Okay, see you in a few minutes.
Yeah, sure. Thank you. I'll just
Okay, I'd say we could slowly start if Ved is ready.
Yeah, I'm ready. Should be good.
Okay, so welcome to the final presentation of this stream on DSC DACH. The last one will be by Ved Prakash, if I'm saying that correctly, and he'll be talking about Snowpipe fundamentals, ingesting streaming data into Snowflake made easy. Ved, the stage is yours.
Yeah, thank you. Thanks a lot for this. And let's start with this presentation and the tutorial. So, welcome everyone. So today we are going to discuss about the Snowpipe fundamentals. We'll have something which is basically talking about ingesting streaming data into Snowflake made easy. That's the way I see that because it's one of the easiest way to bring data into Snowflake without doing a manual intervention. So moving next to this, just before we proceed, setting up little ground rules, we expect the duration of this whole tutorial should be approx 60 minutes, given 45 to 60 minutes. It depends how fast we move. We will have a 15 minutes break and 10 minutes Q&A at the last. For noise, please be muted by default. Q&A, if you want to stop me and ask a question during the class, feel free to drop a question in the chat anytime. All the resources from this tutorial, you should find it on this particular link. I will put this link in the chat as well, and we'll share this presentation so you can have a look. And do not forget to enjoy the course. So moving to next. Meet your host. So I just wanted to give a brief introduction about myself. So I'm a staff data engineer at GitLab, has over 15 years of experience in data engineering, specialized in cloud platforms like GCP, AWS, Snowflake, programming, especially Python and PySpark, and tools like Terraform, DBT, or Monte Carlo. With a track record of leading development of data products for supermarket chains in UK and US, I excel in the full data engineering lifecycle from pipeline design to infrastructure management. I thrive in the collaboration setting, mentoring teams, and creatively solving complex problems to drive impactful business decisions. So over here, I've been at GitLab for more than 3.5 years, and I primarily take care of data platform infrastructure and mostly focus on scalability, reliability, and resiliency of the data pipeline. So that's me. Moving to the next, we'll take a brief on the agenda for today, and we'll be talking about introduction to Snowflake. What is Snowflake like that? Architectural overview and key concept of Snowflake, because that's a very basic ground rule in before we jump to Snowpipe to understand what Snowflake is, what we are talking. This course, this tutorial is mostly starts for even for the beginner who just coming to the new world of the data. And then we talk about the Snowpipe fundamentals, setting up Snowpipe, managing pipe projects for pipe objects. Then we take a break, and given that if we have energy, we don't. We proceed further because the rest of the parts are very small one. That's the monitoring and troubleshooting of Snowpipe, best practices for Snowpipe, which I share from my experience at GitLab, what we have done. A live example that how do you, once you set up all this Snowpipe and all, how the data looks and how fast it comes, and the followed by the conclusion. So let's start on this. So introduction to Snowflake. That's the very first. So what is a Snowflake? So that's the very first question comes in. So Snowflake is developed in 2012. Snowflake is a fully managed SaaS as a software as a service software that provides a single platform for data warehousing, data lakes, data engineering, data science, data application development, and secure sharing and consumption of real-time or shared data. A Snowflake features out-of-the-box features like separation of storage, which you can see, and compute, on-the-fly scalable compute, data sharing, data cloning. These are very critical things which we have seen the way the data world or the data has a landscape in the terms of databases have modified. A Snowflake is one of the leader in that, and they provide the third-party tooling support in order to handle the demands needs for growing enterprise. And there's some of the key things which it's a Snowflake is built for cloud native thing. It's built specifically for cloud. So it can't be hosted on a server, on-premise and all. It's right now it gets hosted at AWS, GCP, and Azure over there. Separation of storage and compute. So Snowflake is the first in its kind where you start separating your database storage and the compute on the fly, so you can optimize or you can scale your storage as much as you want. At the same time, you can scale your compute as much as you want, keeping it as independent of each other, ensuring that different team can get a different compute at the same time point of time. Multi-cluster and shared data architecture. So you enable concurrent access to data without performance degradation. So that's what I said. Our team wants a same data sets, a same table, if needs to be accessed by a sales team and one by the marketing team and one by finance team. You can give a dedicated compute all to three of them, where they are using their own compute, but they are querying the same data set which is stored in the storage. So that's the multi-cluster shared data architecture which comes with Snowflake. Support both structured, semi-structured, and unstructured data. Data sharing capabilities comes with Snowflake, where you can share your data with your fellow Snowflake users who are a Snowflake account, or even the people those don't have a Snowflake account, by creating them a read account where they can read the data without even pushing the data out of your database, which was not possible in the older time. Snowflake gives you a good feature of time travel, where you can travel through the time. Basically, you can travel last 90 days to see that what has changed or what has been modified or how the data has been modified. So it reduces the need of having a database backup kind of thing, that you need to have a database backup to be taken. If not required, it gives you 90 days of time travel over there. A zero copy clone, which helps you to clone the whole object, whole table, without taking double storage. So if you can just clone an object, basically you take a backup of a table, and if the table and you don't store it twice. A storage security features, basically it includes end-to-end encryption, role-based access control, and compliance with various industry. And the way the Snowflake does the billing is pay-per-use pricing models, offer cost-effective solution by charging only for the resources used, and they charge you per second. So that's a really good thing. Support the asset, they provide cloud service to the maximum, or AWS, Azure, and GCP, all the three which is present. And understanding the Snowflake capability is crucial for any organization to modernize their data infrastructure and leverage the power of cloud-based analytics. In this diagram, if you see, which is seeing on the screen, it is a database storage, which is the storage layer. Then there is a query processing, which is a virtual warehouse. This virtual warehouse, you can think of like are basically the heart of the processing, where you have a certain RAM and a disk associated, and where you do the processing. And then you have a cloud service layer where you have the UI to interact with the Snowflake. So authentication and access control, infrastructure service manager, optimizer, metadata manager, and security. So these all things get bundled as part of one, and that's what makes Snowflake unique. Moving further, the architectural overview and key concept, would like to briefly touch upon this. So if you see, the center of all of this is basically the database storage layer. It's a centralized storage for all the data. It contains both a structured, means all three types, structured, unstructured, and semi-structured data. Automatically manage the Snowflake, manage the data distribution and optimization, and supports various data formats. Then comes the query processing layer. That's the compute. That's the elastic compute, what they have built it, which has a virtual warehouse for executing queries, a scalable and independence of storage. So the compute is always separate from storage. You can have asset, you can have as much storage as you want, but you will have as much compute as you can need it. Multiple warehouse can access the same data concurrently. That's explained earlier. So that's the whole elastic compute, and then which is surrounded by the Snowflake introduced Cortex AI, which is the Snowflake provided AI services, which comes with the Snowflake Studio and the models and chat APIs, where you can talk with the data. So that sits on top of the elastic compute. And then comes the cloud service layer. And the cloud service layer manages the metadata, security, overall administration, security and compliance, optimization, performance, administration, availability, everything. So that's the cloud service layer. And on top of it, which that comes with the cloud service layer, that a Snowflake support various client connectivity. So supports various clients interface like ODBC, JDBC, Python connector, web-based UI for administration and query execution. And to put something on top of this, that they have the called Snowgrid, which is a cross-region, cross-cloud data sharing capability. That's the new thing which is happening, which is comes in the Snowflake as a architectural change, or the way they have designed to build this application, because of which they can do seamless data sharing and collaboration across the cloud, cross-region, and do whatnot. Some of the key concept, just touching it upon, when you become familiar with Snowflake, you will learn about virtual warehouse, which is basically a scalable compute cluster for query executions. Micro partition is a data automatically organized into micro partitions, enables efficient pruning and data escaping during the queries. Time travel, ability to access historical data at any point of time within a retention period. By default, it comes for 90 days, and for this. And zero copy cloning, create instant copies of data, schemas, or table without duplicating data. Data sharing is another thing which comes the key concept, where you share the live data, governed data across a Snowflake account without moving or copying the data set. We have a role-based access control, which is a fine-grained access control to a Snowflake object, hierarchical roles for flexible permissions and management. Dynamic data masking is basically make sensitive data based on the user roles and permission, protect data privacy while maintaining data quality utility. And then materialized views, which is a pre-computed result set of automatic. So understanding this key concept is essential for effectively leveraging a Snowflake capabilities and optimizing your data warehouse implementation. So that's why I've just touched on briefly on this. And we move to the thing which is a Snowpipe. That's the one thing which we came to talk about and learn on this tutorial. So Snowpipe is, what is a Snowpipe? A Snowpipe is a powerful feature in a Snowflake that enables continuous automatic loading of data into Snowflake tables. It provides a real-time serverless data ingestion service that automatically loads data from external stages like S3, Azure, Blob, Storage, or GCS into Snowflake tables as soon as the data becomes available into that object storage. So if you look at this, a file gets uploaded to S3 bucket, AWS S3, and that triggers an AWS, as soon as the file lands, the S3 bucket sends an SQS notification to Snowpipe that a file has come, and the Snowpipe is responsible to pick up that file and load it into Snowflake. So that's so key features of this Snowpipe is it's automated, continuous loading data loading system, support for various file format, that is include CSV, JSON, Avro, and Parquet, make it versatile across for different data sources. Integration with cloud storage provider, seamlessly works with major cloud providers like AWS, S3, Azure, Blobs. So that's something like it can integrate a scalable and serverless architecture. So this is a one feature within one of the feature of Snowflake, where it is a serverless architecture. Error handling and data validation. So you can validate the data, you can handle so you can, by default, it comes a built-in mechanism to handle errors and validate data during the ingestion process, ensuring data quality. Near real-time data availability. So data becomes available for querying within a minute of being staged, enabling timely analysis and decision making. So that's one of the, so you don't have to, it's like a real-time, almost real-time streaming services. Cost effective, pay only for the compute resources used during the data loading, optimization cost for data ingestion. Automatic file discovery, a Snowpipe can be configured to automatically detect and load new files as they arrive in the staging area. And then the REST API support. So Snowpipe can be triggered with like when you place the file, and then it can be done automatically via AWS or services like SQS, SNS notification, or you can make a REST API call to upload the file as soon as you land it. So if you have a third-party service which is like placing a file somewhere, like to another S3 bucket, and that file is placed, and as soon as the file is placed, it can make a REST API call to enable a tell in Snowpipe that the file is present over there, pick it up and load it into Snowflake. So understanding this aspect of Snowpipe is crucial for implementing a Snowpipe and a real-time data ingestion process. So if we look at the Snowpipe architecture, it contains, it's a combination of external stage. Basically, external stage is nothing in a Snowflake, but it's a cloud storage location. It can be like S3, Azure, Blob, or GCS, where data files are initially stored. Servers serves as the source of data to be loaded into Snowflake. So in this diagram, which you see on the board, Amazon S3 is an external stage for this. Pipe object, it defines the connection between the external stage and the target table. So that's the Snowpipe, which says that load this data from data which is present in this external stage to a Snowflake. And that's what we call the pipe object. Cloud storage event notification. And that's what we call it as SQS service. You can use three things, which comes as it can be Amazon SQS in AWS, or you can use I think there is a Google function which can be used again to notify in Google. It works like that. You can use Amazon SNS service, simple notification service that can be also used to trigger the Snowpipe when you get the event. Message queue, which is Snow, and then the REST API. You can also do a monitoring and logging, so provide detailed information about the Snowpipe operation, including error reporting and performance metrics. We will see a little bit more further on this when we do this, proceed further. And little bit like on the how the Snowpipe work. So there is a two-way to do a Snowpipe or to trigger the Snowpipe. One is automating a Snowpipe using cloud messaging service like SQS, SNS, or Cloud Function, or calling a Snowpipe REST endpoint. If you're calling a Snowpipe REST endpoint, you use function like AWS Lambda kind of service to make the REST endpoint call. Or if you're using the automated Snowpipe using cloud messaging service, then use configure cloud storage event notification, S3 event notification to automate Snowpipe about the landing of the file, or SNS notifications setting to send SNS notification. So with this, we move towards the installation. And I think over here, we will do practically try to create all the setting of which is required to set up a Snowpipe, that is creating an AWS S3 bucket, create an IAM policy to access the S3 bucket from Snowflake, creating an IAM role, and all the other steps which is mentioned in this slide over here. So with this, I would like to pause the slide presentation and would like to go to S3. So a prerequisite, which was, I'm not sure it was explained, but in order to do this whole tutorial, you will need to have two things, which is required by default is you should have a signed up for a Snowflake account with appropriate permission. So you can create a trial account in a Snowflake, which comes for 30 days of free service. You can find that I put it in the Slack, the place to create it if you are not already aware of it. And you can also sign up for a trial account for AWS, which will be again available for certain $400. That's good enough to complete this hands-on thing. The whole README about this whole tutorial and the study material is also, I posted it over here to go along with the whole process of the step-by-step process, what we will be following up to create this whole S3 bucket, right from creating the S3 bucket to going towards and creating a table in a Snowflake and loading data over there. So before I move towards that, so this is basically how the Snowflake UI looks like. You can go and create a new worksheet. You can rename it whatever you want to do. And then by default, when you create this account in a Snowflake, you're logged in as account admin because that's the super root user in a Snowflake. So that's one thing in terms of that. So that I have already signed up. I have used, so when you do a sign up for like app Snowflake. Snowflake for .com, you can be asked to sign up, and then you see that which cloud provider you want to host your Snowflake account. So I have hosted this in AWS London, and I am creating all my objects in AWS also in the services and in London, it's same reason as well. To just to keep it in sync, but it doesn't matter in which region your buckets are sitting and which region your AWS, your Snowflake account is there. It can integrate. It has nothing, those two are not related. It's just to keep it simple, I just kept it in AWS, both the thing. So, to start with this Snowpipe installation, the very first step, what we need to do is to create an S3 bucket. And because that's the place where you will be placing your object. So in order to do that, I'm going to create a bucket called the Snowpipe fundamentals over here. And this is something which is a Snowpipe. So I go click on create bucket. I type, and this bucket name has to be unique. So if I have created a Snowpipe fundamentals, then you won't be able to create the same because it's a globally unique bucket name, what has to be there. The object ownership is ACL disabled, so I just use the same recommended. A block public access, bucket versioning is disabled, tag, rest all things remain same. And we go ahead and create the bucket, and that's the very first step we do. In the documentation, you can see all the snapshot, what all has been created, has been done to do this. Once the bucket is created, the next step is to go ahead and create an IAM policies. So the way it works that you have created an object, now there where the file will come and sit. But now you need to define a policy which will set up the appropriate IAM roles to allow a Snowflake to access this bucket, because a Snowflake is not aware of that there is an S3 bucket sitting somewhere in some cloud provider. So we will go ahead and create an IAM policy for this, and we'll say that, so we go to IAM policies, we'll say create policy over here, select a service over here, and sorry. And when you go over here, you click on this JSON because the JSON is provided already. So you don't have to go and go with that policy editor. So you click on policy editor. And over here, remember to substitute the bucket name which you want. So I have defined my my bucket name is a Snowpipe fundamental. So this policy is saying that allow S3 list bucket for also Snowpipe over here. And once you do that and edit it, you click on next. You can define the policy name and that a Snowpipe Snowflake a Snowpipe access policy. And that's we do it, and it should go ahead and create a policy for me. Now this policy has been created. Policy means that in AWS, most of the people who are already aware of AWS would know what it means, but just to give a brief around for everyone knowledge, that policy is basically saying that I have set up a rule, that this rule says that you can list all the object in this particular in S3 bucket. On this particular in this particular S3 bucket, that is, you can read all the, you can list and you can read all the files which is getting loaded over. Now this is a policy, this is a rule which is defined, but it has not been attached to any role. So that's what we're gonna do next, that we will create a role, and role is something which says that, okay, this role is mapped up with this policy, and this policy has the access to say that you can list all the roles. So next thing what we're gonna do is to go and create a Snowflake a policy role over here. So you go to role over there. Just a second. Oh, sorry about this. Yeah, sorry about that. Yeah, so Snowflake a Snowpipe role, and that's what I'm gonna go and create next. So I go to the roles, I say create role, and that is for AWS account. And over here, when you look, when you say AWS account, trust entity type AWS, this account is this required an external ID. And at this point of time, the external ID, what we're gonna put is like just use 000, but this will be required in order to, when you move further, this will generate an external ID back, which will be mapped to a Snowflake in the coming thing. So now what we are doing that we are creating a role, and to this role, we are saying that map the Snowflake, a Snowpipe access. That's the policy we just created before this role. So we are saying map this role to this, give this role a name. So I am giving this data science config Snowflake access over here, and a Snowflake to access, and just a description. Access. Oh. And you can see that external ID, what we have set is, and remaining things remains as it is. And we go and click on. Okay. Then this got created. One second, let me just check. Oh. Okay, I delete this. How about that? I was doing this before doing this at the lab, and it didn't got cleaned up. Yeah, this should create my role. And if I search the role over here, I get this ARN number. So when you see this, you have to save this ARN number because this will be required when I move towards a Snowflake. So this ARN number comes over here, and then I move towards Snowflake. When you move, because now you have created, so what you have done till now, or what we have done till now, is that you have created an S3 bucket, then you have defined a policy which says that this are basically an access rule, which says that as per this policy, you can list and you can read all the object in this particular S3 bucket. Then you have gone ahead and created a role, and that role you have defined, mapped it to that policy, which saying that this IAM role has this policy attached. It means whichever user which has access to this particular IAM role or try to access AWS services using this role has this policy to list and read the object in this S3 bucket. So that's what we have defined at this point of time. The next step, what we're going to do is that we go ahead and try to create a storage integration between S3. And so storage integration is nothing but just a seamless integration between a Snowflake and AWS or any of the cloud provider, where you do this integration without setting up any where you do this integration without setting up any username and password access. Like generally when you create an S3 bucket, you get an access key and a secret access key, I think so. And that particular you define it to create an external stage. But in this world, the way we are setting this one up is that we will set up this policy and this role where you won't have to do this uh, username and password thing. So we'll create this integration one, and that should hold on to this. So copying over the ARN role, which comes from here, which I have copied, and I will try to create the S3 role integration and this something, and I'm over here. Don't forget to modify your S3 bucket name over here and substitute it. The command is this particular query is already present in the in the documentation over there with the snapshot. So I will go ahead and create this a storage integration. And when you do a describe on this description of on this storage integration, you get a certain set of values over here. Basically, you get a storage IAM user IAM, external ID, a role ARN, and this kind of thing, which is required. So you need from this setup three things: IAM user, external ID, those two things, because that will be required. And this is the role. So if you see in this description or in this integration, you can see that AWS role ARN is basically your role which is present in AWS account with the role which you have IAM role which you have created. So this is this role. So now the next step for this would be that now I have given an created a policy and a role, and now I have created an integration. But I need to inform the IAM role back to in the AWS that this is the trust relationship. So basically, so a Snowflake will try to access from this user, a Snowflake user will try to access the S3 bucket using the IAM role. Now, the message or the information has flown from AWS to Snowflake, and we have informed Snowflake that this is the role using which you need to access the S3 bucket. But again, you need to update AWS as well back, saying that these are the what do you say, the AWS ARN number of a Snowflake and the external ID to which you should trust if the request is coming from there. If the request is coming from somewhere else to access this S3 bucket using that particular role which we have created, then don't allow it. That's what it is trying. So basically, we have to build the trust relationship. And for that, we need to again go back to our role over here and where we and click on the trust relationship on this particular UI. And when you look at this trust relationship, you click on edit trust policy, and over here, you need to substitute the two values which we are getting from here. That is storage AWS IAM user ARN, which comes and sets at this place. And then the external ID, which is this. And then you click on update of the policy. And this policy has been updated. And now the trust policy is set that when you create a stage and then you click on list, you will be able to see the object in the S3 bucket. Moving further, we move towards what we have done till now. If you look back to the setting up the Snowflake, we have created the S3 bucket. We have created an IAM policy to access the S3 bucket from a Snowflake. Integrated IAM user with a Snowflake storage, IAM user permission. The next step is to go and create a pipe, when we say pipe, it is a Snowpipe in a Snowflake. And that's all the things which will be happening now will be happening mostly in the Snowflake console over here. So I have created already a database, but we can run and repeat the command over here. So the first step would be to go and create a database where you want to create this whole object and create the Snowpipe and all the things over there. So I created a database called a Snowpipe fundamentals. I go ahead and create a table within the public a schema of the database. And this is the next step where, so in order to read data from S3 bucket, you need to create a link between a Snowflake and that. So there is a two aspect. So you need to establish, we call it external stage within a Snowflake. So over here, we are creating a stage called S3 stage, and we are using this schema public, and we create it over here. So if I do this external stage, and if I say that list S3 stage, if everything is done right, then you should see this. There is no file over there, so you will not see any file, but you can see that the connectivity between a Snowflake and S3 bucket is there. It has been set up nicely, because that's why you can see this object. Otherwise, this command should have thrown the error at the way. So this is your first test or first validation that you have created the object in the correct manner, or we have created the object in the correct manner. The next step is that we go ahead and create the pipe. So basically, pipe is a Snowpipe. So create or replace. So the command says that create or replace. So there's the pipe name. You say auto ingest is equal to true. It means that when an object is created, as soon as the file is created in the Snowflake, it ingests the data into the table defined. And when a Snowflake loads data from an external, only way to load data into Snowflake is using copy into command. So that's the way the data moves into Snowflake at any point of time. Either it is a Snowpipe or you're manually loading, we use copy into command. So this command or this query, what it says, a copy into the table which I have created, Snowpipe fundamental tables, from the external stage which I have defined, public S3 stage. So whatever files comes into S3 stage, you can make it for the ease of this session and to make it simple. I have just said that whatever file comes in that bucket, load it into this particular table. And I'm expecting that file to have just one column. If it has more than one column, it will throw an error. But you can define it more rules and regulations. You can put it in when you create this S3 stage, where you say that the path, you can define it further, saying that only CSV file or file with a prefix this or a profile with suffix this, that file only you should show me in this stage. Even though the stage has millions of files, I am only interested in the file with a DSC underscore date dot CSV file. So the date part, you can put a regex and do a lot of things, a lot of magic things over there. And we can just list the file which you want to. You can also define a file format, which I have not done and for this session, just to keep it simple. But you can define file format, which will be, you say that I want to pick up the file. So file format is nothing which you define that a file has if it is a CSV file, but comma is not the separated, pipe is a delimiter in the file. You can define that in file format, saying that it is a CSV file, but the delimiter is pipe rather than comma. So don't look for comma and look for pipe over there to do the delimitation. So once you proceed further with that, so you have pipe and external stage. These things are required, and a stage will be used to, you can map the pipe or the file format to the stage as well. So a couple of things which can be done when you look deep into creating in the stage and the Snowflake documentation, you will figure it. So we'll go ahead and create the pipe. And once you create a pipe over here, what you can see that you should get an answer over the pipe S3 pipe created successfully. Now, what we want to do next is that we want to ensure that a Snowflake user, so not any user who uses this Snowpipe should not be an account admin, because account admin is like a super root user within a Snowflake. So the idea is that you go and create a dedicated role, and that role is mapped to all the users. So in a Snowflake, the RBAC policy is that role-based access control. You don't give grants directly to user. You always give grants to a role, and that role is mapped to a user. So what we will be going and doing next, that we'll go and create a new role, which will have all the access to manage this Snowpipe object within a Snowflake. And for that, a Snowflake comes with 3 roles. With 4 roles now with a user role. account admin, security admin, sysadmin, and user admin. So account admin is the root user who can do both permission grants, create the warehouse and everything. Security admin is the one which manage all the security related thing. And sysadmin is the which manages all the object within that particular account. So we are using security admin because we want to create a role and we want to manage grants and permissions. So we go ahead and create a role, a Snowpipe access, and if we look, we'll try with this. Generally, it takes like less than a second or so. Hopefully, this should work this time. Okay, so it has created, replaced the role. Now I grant the object the permissions, and these are the 4 statements which we use to grant object access and insert permission to Snowflake, to basically the Snowpipe. And now I need to transfer the ownership to this particular new role as Snowpipe access. But when you run this transfer the ownership, because when you started the pipe, the Snowpipe, and if you look at the status of the Snowpipe, it will be running, it will be up and running. So if you see the status of the pipe, it is running at the moment. So at this point of time, if I try to transfer the ownership, it will throw you an error because you can't transfer the ownership and object if it is already running. So what we have to do is we have to pause the pipe first, and then we go ahead and transfer the ownership of this object. Then I'll have to assume that particular role. And then I pass this ownership to my role. So I am the user with Prakash 1995. So this role has been granted to me, and this is my default role. So when I log in next time, my default role will be a Snowpipe access. That will be the role. So if I right now over here, you see on the right hand side in the console, it's a security admin. So if I say use role Snowpipe access, it will change my role over here to Snowpipe. And when I click on show pipes, I should be able to see the pipe which I have defined or which I have created. So now so once we have created the pipe now, and we should resume the pipe as well back. And this is operation is running. So if I go ahead and check the status of the pipe back, if it is running or not, it should show me. It's running back. So moving further on this, so now we have created a Snowpipe, and that is Snowpipe is the ownership has been transferred. But one thing which is still missing in this whole puzzle is that configure the cloud storage event notification. That is, we should be, I'll try to move away from the screen and come back here if it is. Once. We'll stick over with this one and we'll juggle with both. So what we have to do next is that we need to set up the S3 event notification, basically for a Snowpipe. So basically the part where I said that when you place the file into S3 bucket, the bucket should notify a Snowpipe, or basically the AWS should notify a Snowpipe that a file has arrived so that a Snowpipe can load the file. So in order to do that, so what we will be doing first would be, we'll go and check over here with show pipe. Sorry. And we copy this notification channel, this particular value. This is the ARN value. So when you click show pipe, you pick up this value, and then we go back to our S3 bucket. Over here, Snowpipe fundamental over here, which we have created, and click on the properties and scroll down, and then there is an event notification. Over here, you can define Snowpipe application, leave other things blank. It's basically all object creates, so put, post, copy, anything happens, it will create an event over here. And moving there, you say SQS service, and then you need to enter the SQS URL. And this is this particular value which we will be entering over here. And then you save the changes, and this should be active over here as a Snowpipe notification. So with this, I think where we are is that configure the cloud storage event notification. And I think we'll play a little bit more on this, and then we will take a short break of 10 minutes. Short break on this for managing pipe objects. So now what we are till this point of time, what we have done is that we have created a Snowpipe. You can look over here, and in the public schema, you can see the pipe is present over here. You can look at the definition, what has been created, what is the status, it is execution is running, what is the notification channel, and all the things are present is set for this one on this aspect. The next part which I wanted to highlight and wanted to walk you through is how do you pause or how do you manage this pipe object? So in order to the commands are very simple. If you want to pause the pipe, you just set the pipe execution is equal to true. It's a pause is true if you want, and if you go ahead and then again check on the status, you keep coming back to this command back. So it's paused. If you go ahead and if you say that I want to resume the services, it can happen. It depends upon the need. If you want to pause the pipe because there is an outage or there is a wrong files getting pushed to the S3 bucket, you don't want a Snowpipe to load all those junk files, then you can do this kind of activity. And again, when you come over here, you can check on the status of the pipe and you should see that it is running. So the other command which is useful when it is required is like basically we call it a drop pipe command. Basically, you can drop the whole snow pipe which you needed, and that is dropping the pipe does not means that it affect any data. It has just dropped that pipe thing or the connectivity which was loading data from S3 to Snowflake, but it is not dropping the data which is happening as part of this. So if you have dropped the pipe, or you have a couple of caveats which wanted to highlight, is that when you are, I think we'll be covering up a little later, but caveats that if you're dropping a pipe and recreating it, it might means that you might reload the whole data which is present over there. Few things which happens on a Snowflake when you place the file into suppose a file was placed dummy.1 today, and again you place the same file tomorrow. It will not load that file into Snowflake. It will treat this as the same file, and if the file, because it has replaced, so it will maintain the metadata of the file size. So if the size of the file and everything remains the same, a Snowpipe maintains the history that this file has already been loaded into Snowflake. So it won't go ahead and load the file again. So with this, I think we'll take a break for 5 minutes or 10 minutes, depends, or we can take a vote, we can continue because I want to show that how the data, because right now my table is empty. I don't have any records in it, and we can see how we can load the data. So shall we take a break for 5 minutes and then resume back? Okay, and then I will proceed with this, I think, because it should then wrap up a little early. Then, so let's proceed with our further on this, and that is basically monitoring and troubleshooting the whole thing. So okay, so with this, I'm skipping the break because I think the next part is more interesting and more. So how do you monitor and troubleshoot the Snowpipe? What happens if the Snowpipe fails and in that kind of scenario? So there is a command which you have already seen a couple of times. I have used this particular highlighted command, which tells you the status of the Snowpipe. So that's what we see, that if a object is not getting loaded, then you first go and check that is the pipe running, and it should, if it is saying that it is running, it means that just not running. It gives you further more information that pending file count is 0 because there is no new files. Notification channel is this, so it is running and there is no file count. So that's the first place to know. If you need to manually trigger a Snowpipe to process any file that haven't been processed yet, you just want to reforce it, then you can use the command alter pipe like this, which is refresh. So this will be used to refresh the pipe itself, which will load the object which is not present, which has not been loaded. In case sometime it happens, then we can use this particular thing for troubleshoot out. If you need to see the pipe error, what we have, this is a query which I have used a couple of times, basically to see that pipe usage history. So you won't see anything now, only when something has been loaded, and which we'll do it next while placing some dummy files and see that it happens. And we'll come back to this query again. If you want to see the load history, that how many files have been loaded, you can see over here. And if you want to see the list of unprocessed files, basically what you do that you go to the stage and see what are the files present on. So these commands, just keep in mind, let's see a demo of this, the whole thing, the moment of fact that if it is working, what we have been doing. So what we will do that I have created two dummy files for this just which contains the information like I should bring it to this screen. So I've created this dummy file one. And it will be dummy two. And we upload this file one by one into Snowflake to the bucket. This can be done programmatically. What happens, that's how we do it. But just for this tutorial, I'm doing it once. So I'm doing one file and I'm saying upload. And if I see over here, I see the file present over here. Now I need to look at this stage. I can see that the file is present over there. If I go and look at my pipe status, it says the pending file count is 0. So is the data loaded? So yes, the data has already been loaded over here. So why it is not? It is the old file which has got loaded. So I will load it again. So the size has changed. The MD5 value has also modified. We need to look that if this data gets loaded, it's running, shows. It shows that the file has loaded, the row count is this. But since the file name is still the same, it is not going to load the data. So I need to rename my file in order to do it. So what I will be doing is I'll rename it for and upload the file again back. Basically, what I'm trying to show over here is that as soon as you upload the file, it gets loaded. So if I come over here, I should be able to see both the files. And if I query the table, I should be able to see the load history, it's still showing one. Yeah. So the data is here, which comes from these are the row number 4, 5, 6 are part of the dummy 3, the other file. If I upload again the next file again, it will just keep uploading instantly to a Snowflake. So that's what is, if I say load these two again, and I should see, even though I upload the same, S3 bucket itself knows that it is a duplicate, it takes care of that. And when I move over here and see in my stages, IC3 file, and it will come in a minute back to. So the file has been processed. And if I look at the load history, it is still showing 2. So it should show me in some time 3. And as soon as you see 3, it means that the file has been loaded to the table, which has still not. Now it shows 3. There is a file number 2 which has been placed. And if I go ahead and look for the data, it is present over here. So this is on the monitoring front, best practices, and something which I would like to give this as a highlight that what we should do, that it is always good to join a Snowpipe error notification service. So what happens that within a Snowpipe, if you are monitoring, you're not monitoring that the Snowpipe is failing or not. That's what I have not shown in this particular example, but if I had time, I would have shown that, because for that, what we do is that a Snowpipe can push error notification to cloud messaging service when it encounters errors while loading the data. So the notification describes the error encountered in each file, which enables analysis of the data in the files. So what we basically do, or what we have done at GitLab and over here, is that when you create the Snowpipe, you also tag it up an SNS service over there. You say that if the pipe has failed, the copy command of loading data into a Snowflake has failed, then trigger this alert, and we should trigger an SNS service, a simple notification service in AWS or in Google Cloud, a cloud function, which will go and send a message, an error notification to your desired or defined notification method. That it can be mail, Slack, or pager, wherever you want to be. So you should be notified. So I think that is something which we should do, that we should keep the flag of a Snowpipe to set it up like on error in the Snowpipe documentation. You can see so integration and AWS SLS topic and command. So it's this something which you can enable it on the Snowpipe, the copy into command which you set it up to fail. If it is failing, then it should throw an error. So with that, those are the best practices. We have already gone through the live example of uploading the file, which is part of this tutorial, that you set up all this thing, and you set up all the slide back to this and moving here. So coming to the conclusion. So I just want to conclude with this, that what we have seen as part of this tutorial is that you have created a S3 bucket, you have created a policy, you have defined a role, then you have mapped that role to a S3 integration. Again, you linked back AWS, a Snowflake object by the trust policy to AWS, and that's established that you can list the object in the external stage. Then we went ahead and created a Snowpipe, a simple pipe over there with normal copy command. And that copy command is referring to an external stage, which has been also defined by us in this tutorial. Then we enabled that Snowpipe And we went ahead and edited the properties of the S3 bucket, enabling a SQS service saying that if a file has been placed to this S3 bucket, you should go ahead send a simple queuing message to Snowpipe that a data has come. And that's when the data gets loaded. We also looked at some of the commands which enabled us to load data into a Snowflake, and plus it also enabled us to see that or validate that in terms of failure, what we need to do and what has to be done. So in conclusion, a Snowpipe is a powerful and efficient tool for automating data ingestion into Snowflake. So you don't have to write a complex code, a complex pipeline that if a file has arrived, then go ahead and load the data. It can be just done. So it provides a seamless, near real-time solution for loading data from external stages into Snowflake tables. By leveraging cloud storage, event notification, and serverless compute services, a Snowpipe eliminates the need for manual batch loading. It can be done by itself and ensure the data is available for analysis quickly. So the key takeaway from this tutorial is the importance of proper setup and configuration of cloud storage permissions and IAM roles, the process of creating and managing a Snowpipe object within a Snowflake, best practices for monitoring and troubleshooting a Snowpipe operations, and the flexibility of Snowpipe in handling various file formats and integrating with different cloud storage providers. So remember to regularly monitor your Snowpipe operation, optimize your configuration based on your specific use cases, and stay updated with the Snowflake latest features and the best practices to make the most of the powerful ingestion tool. Here are the resources, which I think I've already given the chat window. And this is me. If you want to connect with me, scan the QR code. You can ping me and ask me questions around this, or even the page which I have shared. It's an open page. You can create and merge request and ask the questions over there, and I'm happy to answer around this. It may be something maybe little outdated or maybe going wrong here and there. I'm happy to get corrected. So please provide your feedback on the same. And with that, I will open the floor for question and answers. Thank you everyone for listening to me. It's been an hour. So yeah, thanks a lot and open for Q&A.
Hi, I'm back. Yeah, thanks, Ved, for a great lecture. So everyone, if you want, you can either type the questions in the Q&A. Have you sorted out the 404 error? So Christian said he can't use the GitLab link.
Oh, is it?
Yeah.
Oh, okay. It
Try
should be.
send it again.
It's a public link. So 1 second, just a second.
Yeah, so until Ved comes back, I would just like to remind you that tomorrow starts the live part of the DACH conference, and tomorrow at 8:30, it is the start of registration. You should pick up your badges at that time. Okay, Ved, did you figure it out?
Yeah, I think so. I gave this is a public repo, so I'm sure it should. I missed the.
So there's a problem with messages on Zoom, so I'll try and resend it. Maybe they can see it now and try it if.
Yeah, if they can't, then I will try to do the setting. If you can,
just give us some sign that the link works if it works, please.
Yeah, please, that would be
I'll
great.
also check it out. So, okay. Christian, if you could confirm if you can access that repository, because I'm having some trouble.
You are also not able to access?
Yeah, let me.
Okay.
I'm having some some trouble with my browser, so give me a second.
Oh,
Okay, let me just check this out. Yeah, it's still 404 not found.
okay.
Yeah, Christian
That's
says the same.
yeah, I got that. Just looking.
Maybe you could like manage this technical difficulty later, and you could
Yeah,
answer some questions while we still have time.
yeah,
Still
yeah, yeah. I'm just checking on that. I think it should. I will
okay.
try
And
to.
if you have any questions, feel free to ask them. Christian just says thank you. I'm not sure if that means
Is it
that
something can you access now? Can you please try?
I'll try. The talk was very interesting, says Christian.
Thank you.
Yeah, let me check it out. No, unfortunately, no.
No. Okay.
I still can't access it. Yeah, Christian says the same.
Sorry.
Okay. Are there any more questions from our other attendees or question? Christian, do you have another question? That's also okay. So if that is all, Ved,
Yeah,
I
I can send this. Yeah, if you can, I will share my presentation over the email, and I will also fix that link. So when you open the presentation, then you should be able to see the repo over there. So I will do that,
okay.
and I will fix it. So I need maybe I'm doing something wrong, and I think I've created this repo today morning. So I think something I've done wrong over there. So I will just
Oh,
fix it to make it public so that people can see it.
okay,
I will,
okay.
I will do that. I will share it all over the email.
Thanks again for a great presentation.
Thank
And
you.
yeah, see you tomorrow at the live part of the conference.
Yep. Thank you. Thanks a lot. Thanks a lot, everyone. Thanks for listening to me. Cheers.